Hey guys, today we're going to look at properties of logarithms. Before we do, let's talk about the parts of notation for a logarithm. First of all, log stands for logarithm. The little number is the base. And then whatever number follows is known as the argument. So let's put an A here for argument. Okay, so log stands for logarithm, B is the base, and A is the argument. And then let's go ahead and look at the three properties of logarithms that you're going to need to know. Okay, the first one, we have log base B of m times n. Okay, so whatever number we have here, if we can break it down to two factors, then we can rewrite this as log base B of m plus log base B of n. Okay, so if you can take that number, whatever argument is here, and break it down to two factors, you can split it up into two logarithms. Another very important note I want to bring up right now is that the answer to a logarithm is an exponent. We'll just call it E for exponent. Okay, the answer to a logarithm is an exponent. I'm going to say that over and over again. You need to remember that. Okay, let's take a look at the quotient property. We got log base B of m over n. Okay, that breaks down to the log base B of m minus the log base B of n. Remember what I said in class. Logarithms represent the inverse of exponents. Inverse of exponents. Remember when multiplying like bases, you add the exponents? Think about this. Here we're multiplying, here we're adding. So when we're adding two exponents, we're multiplying the two arguments together. Here we're subtracting. Remember that goes with division under your exponent rules. Okay, the power property goes like this. Log base B of some argument raised to the k power. Now here we have the power to power. Do you remember the exponent rules for power to power? Remember, this represents an exponent and it's being raised to another exponent. Yes, it's multiplication. So we take k times log base B of m. Okay, so those are our three basic properties of logarithms. We'll be learning some more a little bit later. It says use the above properties, and that the log base 4 of 5 is about this, and the log base 4 of 10 is about this, and the log base 4 of 15 is about this, to approximate the value of each logarithm. So log base 4 of 100. So we want to take these arguments and make them into 100. So for example, 10 times 10 is 100. So we could do log base 4 of 10 times 10. So we rewrote 100 as 10 times 10. Okay, now we apply the property which says when multiplying you add So we're going to have log base 4 of 10 plus log base 4 of 10. Okay? Log base 4 of 10 is 1.6610 plus log base 4 of 10 again, 1.6610. All right, we end up with 3.322, and that represents log base 4 of 100. This is an exponent. So if I take 4 and I raise it to this power, I'm going to get 100. Let's see that. If I take 4, the base, and raise it to this, remember this represents an exponent, we should get pretty close to 100. And we sure did. Okay, let's take a look at the next one. 75. How can I get 75 out of these three numbers? Either multiplying, dividing, or raising one of them to a power. So let's see. 15 times 5. That'll work. $15 times 5 is 75, so we broke it down into its factors in this case. And now the rule for multiplying is to add. So we're going to add these two together. So we're going to have 1.1610 plus 1.9534. Adding them up. And we get 3.1144. Okay, now 3. Well, I don't think multiplying is going to work this time. So we might try dividing. Can we divide any of these arguments and get 3? 15 and 5, right, Christian? That's right. 15 divided by 5 is definitely 3. So log base 4 of 15 divided by 5. Okay, breaking it down, the rule says when dividing, we subtract. Remember, these represent exponents. Remember the rule for division? We subtract. All right, so we're going to subtract the log base 4 of 15, which is going to be that minus log base 4 of 5, which is going to be your other one. Running out of time here. Bell's going to ring shortly. But let's take a look. So subtracting the two numbers, we get 0.7924. So what we have here is we have base 4 raised to the 0.7924 power should give us approximately 3. Let's find out. 4 raised to the 0.7924, pretty close to 3. Okay, now let's look at the other property here. The other property, I believe that we can raise 5, this argument 5, we can raise it to the third power to get 125. So we'd have log base 4 of 5 raised to the third power. We would all agree that 5 to the third power is 125. So now, using the rule, okay, we're going to use this one here. When you have an exponent raised to an exponent, we multiply. So we're going to have 3 comes down front times the log base 4 of 5. So we have 3 times our approximation for that log, 1.1610, and that's going to give us 3.483 approximately. Okay, now this is going the other direction. Okay, Here we have subtraction. So we want to write this as a single logarithm. So going back here, we have a subtraction. So to write it as a single logarithm, we have to divide the arguments. So we're going to end up with log base 7. And we're going to have 30. First one goes on top over 5. Okay, we can reduce that. And we'll get log base 7 of 6. Okay, number 8. Here we have a number, a constant, times a logarithm. Going up to our properties, here we have a constant times a logarithm. Okay, notice what happens. Where does the constant go? It goes on top of the argument. So this constant is going to go up on top. So we'll get log base 6 of 3 to the 5th power. 3 to the 5th power is 243. So log base 6 of 243. Okay? Let's keep going before the kiddos show up. They're going to be here any second. Adding. Remember your rules. When adding, what are we doing the exponents? Multiplying. Always refer back here if you can't remember. Adding means to multiply the arguments. Okay? So multiplying 15 times 3, we get 45. All right, part 3. Hey, we might get through this. This time we're using properties to solve. So when we want to solve this, we have to combine these into one property. And you know what? Let's save this, and I guess I'll do a short mini lesson tomorrow at the start of class over solving. I hope you guys are having a great night. See you guys tomorrow.